Welcome to the fourth video in Section 4, Persistent FSM. In the previous video, we dived deep into the process of working with persistent actors. In this video, we will implement the replacement of persistent actor behavior via FSM. Let's start! We will implement an account actor that's responsible for managing an account for a specific user. This actor has two states, empty when the balance is 0 and active when the balance is greater than 0. Let's start the implementation. The FSM actor needs a definition for states and data. So let's define states. We have two states. We will define a sealed trait for our states which extends FSM state. We will add a case class to represent the empty state that extends state. And we also extend FSM state, so we need to implement an identifier method that defines the string represent state. Let's add another case class for active state. Now let's define our data. The data will represent the balance for account. So let's add a sealed trait for data that contains the amount value. We have 0 balance as a case object, and balance case class that represents balance. Now we've defined states and data for the FSM actor. But for implementing the persistent FSM, we need to define events and commands as persistent. Let's change events to domain events, because we already have event on FSM. First, let's define our domain events. Think about persist event on this actor. Yeah, it's a transaction. This represents the transaction amount and type, if it's a credit or debit, and if we have accepted a transaction or rejected it. Let's define a sealed trait called domain event. We have two events here, accepted transaction that contains the amount and type, and rejected transaction that contains amount, type, and reason. Let's define transaction types, which will be credit and debit. Now, let's define our command. I think we have one operation that contains an amount and a transaction type. Now we have defined things that are needed for FSM actor and things that represent the operation and events for a persistent actor. We are now ready to start implementing the persistent FSM actor. Our actor will extend persistent FSM trait of state, data, and domain event. We need to override 3 methods before we start to implement our states handler: persistence ID, apply event, and domain event class tag. We know what's the persistence ID, right? It's a unique identifier for a persistent actor. Let's move to the second method. It's called apply event. I think its name is descriptive. If you remember in the last video when we implemented the persistence actor, we defined the method update state, and we called this method after persist event, and when we replayed the event from the journal. Apply event is like that method. The apply event method takes an event and the current data and returns its data. Let's start defining the logic for this method. When the case event accepts transaction with credit, we will calculate the new amount, print it, and then create a new balance. When the case event accepts a transaction with debit, we will calculate a new amount and return the new balance. When the case event rejects transaction, we will print a message with a reason and then return the current data. Let's move to third method, domain event class tag. I think its name is descriptive again. You need to return a class tag for your domain events. Now we will start defining our state handlers. Our actor will start with an empty state and 0 balance data. We've got two states. Let's start defining them. When we are in the empty state. In the cases where we receive an operation with credit, we will go to an active state and apply the accepted transaction event with amount and credit transaction type. In case we receive an operation with debit, we will stay in the current state and apply rejected transaction, and the reason will be balance is 0. Now, let's define what will happen when we are in the active state. In case we receive an operation with credit, we will stay and apply accepted transaction. In case we receive an operation with debit, first we'll calculate a new balance and then check. If the new balance is greater than 0, it's OK. We will stay and apply accepted transaction. If it's equal to 0, go to an empty state and apply accepted transaction. If it's less than 0, we will stay but apply rejected transaction. Here we created an app object that contains an actor system and our account actor. Also, it sends 2 test operations to the account actor. Let's run the app. Yeah, our actor is working. Let's run it again. Excellent! It is replaying the events from the journal and then processing new messages. That's the end of this video. We have implemented the persistent actor in FSM style and used the experimental new feature on persistence, Persistence FSM. In the next video, we will explain another experimental module called Persistence Query. See you!